So this is our problem of the day. Problem of the day. The compound ritonavir is an antiviral medicine that prevents human immunodeficiency virus (HIV) from multiplying in the body. A. Circle and name all the functional groups present in ritonavir. B. Determine the number of sp3 and sp2 hybridized carbons in ritonavir. And then C. Indicate all the primary, secondary, and tertiary and quaternary carbons. So the first thing we have to do is to circle all the functional groups. Okay, so you see that right from here, the arenes are always the easiest. So let's label this as A. So let me write it here. The functional group A is an arene. And then the next one we can see is, you can see a carbon bearing double bond, which is connected to a nitrogen. So this is B. And then B is an amide. So that is an amide group. And then you can also see from here a carbon that is bonded to a nitrogen from here, this aspect. And that is an amine. So C is an amine. And then you can also see here sulfur that is sandwiched between two carbons. So D. And then that D is a sulfide. So D is a sulfide. And apart from that, we can see a carbon bearing double bond which is connected to an oxygen which is connected to another carbon. So this E, and E is an ester. Then apart from that, this group, carbon double bonded to nitrogen, it is called an imine. So F is an imine, the imine functional group. You see that carbon that is bonded to an OH. So Gen is an alcohol. So B says that we should determine the number of sp3 and sp2 hybridized carbons in ritonavir. So in order for this to be simple, let's number all the carbons in the compound. So starting from here, this is carbon 1, this is 2, this is 3, this is 4, and then this is 5, and then 6, and 7, then 8, 9, 10, 11, 12, 13. Then we come to this place, which is 14, 15 is here, 16 is here, 17, 18, 19, 20, 21, 22, 23. Then from here we come to this carbon. Let's come to this, which is 24, 25, 26, 27. Then this carbon 28, and this one 29, 30, 31, 32, 33, 34, 35, and then 36. Okay, so there is an emission that I forgot. There is a carbon here, and this carbon will make it 37. So there are 37 carbons in total. Now, since there are 37 carbons, let's first determine the number of carbons which are sp2 hybridized. Since their carbons are sp2 hybridized, it means that they contain double bonds. So let's look for the carbons that contain double bonds. So you see that carbon 1, so let's list them here. So let's list those sp2 carbons here. So you see that carbon 1 is sp2, it's a double bond. Then carbon 2, then carbon 3, then this carbon 5. And apart from carbon 5, you see that this carbon 8, is also sp2. Then carbon 9, then carbon 10, 11, 12, then carbon 13, this carbon. Then apart from carbon 13, this carbon 18 is also sp2 hybridized. Carbon 19, carbon 20, 21, 22, 23, and then this carbon 37 is also sp2 hybridized. And apart from 37, carbon 28 is also sp2. This carbon is sp2. Then carbon 31, 33. So carbon 31, 32, and 33. So carbon 31, 32, and 33. So these are the sp2 hybridized carbons. So let's count their number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So sp2 hybridized carbons are 21 carbons. So let's check for the sp3. Since there are no triple bonds here, it means that the remaining carbons are all sp3 hybridized. So all we need to do is to find 37 minus 21. And 37 minus 21 will give you 16 carbons. So this is equal to 16 carbons. So the sp3 hybridized carbons are 16 carbons. The last part of the question says that we should indicate all the tertiary. The last part of the question says we should indicate the primary, secondary, tertiary, and quaternary carbons. So a primary carbon is a carbon that is in the form of CH3. If you see a carbon like this is a primary carbon. And then a secondary carbon is a carbon which has two of its hydrogens substituted. So it's normally CH2 with the other substituted. And then a tertiary carbon is a CH with 3 of its hydrogen substituted. And then a quaternary carbon is a carbon that has all of its hydrogens substituted by different elements. So using that rule, you can see that. So using that rule, you see that this carbon has one hydrogen, and therefore, since it is one hydrogen, this carbon is a tertiary carbon. And then this carbon too also has one hydrogen. So this one too is a, let me write it inside. So this is also a tertiary carbon. Then we can see that this carbon, number 3, carbon 3 does not have any proton attached to it, and therefore it comes under quaternary carbons. So it's a quaternary carbon. Then carbon 4 has 2 protons on it. So since it is 2 protons, then it is a secondary carbon. Then this carbon 5, it has got no protons attached to it, so it is a quaternary carbon. So it's a quaternary carbon. And then carbon 6 has 1 proton attached to it. And since it's 1 proton, then carbon 6 is a tertiary carbon. Let's come to carbon 7. Carbon 7 has 2 protons, so it is a secondary carbon. Then carbon 8 has got no proton on it, so it is a quaternary carbon. Carbon 9 has only one proton. So since it's one proton, this is a tertiary carbon. This one too is a tertiary. This is a tertiary. This one too is a tertiary. And then this one too is a tertiary carbon. Then let's come to carbon 14. Carbon 14 has got only one proton. And since it's got only one proton, it is also a tertiary carbon. 15 has two protons, so it is a secondary carbon. Carbon 16 has just one proton, and since it has one proton, it is a tertiary carbon. Then carbon 18 has got no proton on it, so it is a quaternary carbon. Carbon 19 has one proton, so it's a tertiary carbon. This one too is a tertiary carbon. And 22 is a tertiary carbon. 23 is also a tertiary carbon. Then we come to carbon 37. 37 has got no proton on it, so it's a quaternary carbon. Then 24 has one proton on it, so it is a tertiary carbon. 25, carbon 25 also has one proton on it, and therefore it is also a tertiary carbon. Then carbon 27, it has three of its protons attached to it. So carbon 27 is a primary carbon, because remember that we said if it is the protons are 3, then it's a primary carbon. And then it's the same for carbon 26. It also has 3 protons, so it's a primary carbon. Then carbon 28 has got no protons, so it's a quaternary carbon. And then carbon 30 has 2 protons, so it is a secondary carbon. And then carbon 31 has got no protons, so this is a quaternary carbon. And then carbon 32 has 1 proton, so it is a tertiary carbon. Then carbon 34 has got 1 proton, so 34 is a tertiary carbon. And then 35 has 3 protons, primary carbon. And 36 also has 3 protons, so it is a primary carbon.